Last time we talked about the privacy in the blockchain. We will continue this topic this time and talk more about some of technology behind the privacy. First, zero knowledge proof. We mentioned last time there is some variant on the zero knowledge proof. One such variant is brute proving. Brute proving is also a zero knowledge proof, but it has no trust setup. It's basically really fast in terms of get the proof, but the verification side is slow. It can also be used for the aggregation of the proof. So you can aggregate multiple proof into one. So there is a pro and cons on the brute proofing technology. Ethereum Foundation is actively looking at potentially leverage this as well. Other variant on the zero knowledge proof includes ZK Stack is also under investigation. So zero knowledge proof has some other project as well working on that. There's one in China actually they're working on that. It's called SERO, SERO, so they call it serial. It's kind of like a zero knowledge or super zero knowledge proof. Another technology is called the multiple party computing or secure multiple party computing. The idea of the multiple party computing is really simple. It's basically you do the computation without knowing the other counterparty's knowledge. For example, if you have 3 different peoples, they have different kind of salary, and in order to know who earns the most without revealing ABC, the 3 people, how much they earn, exactly how much amount, using this MPC, it's possible to just prove that one of such person, example A, has the most highest salary without even B or C knowing how much it is. Only know the fact that A has the most salary. So the idea of this originally is coming from Mr. Yao, who is a computer scientist in China. He has basically the two-party computing. This is the original idea, but eventually it's more using the multiple party computing. There's lots of research on this subject. It will be very useful for the privacy, both in cloud computing and also in the blockchain, especially in the use of the smart contract. So that's the multi-party computing. Another big one is called homomorphic encryption. There's different kinds of homomorphic encryption. One such homomorphic encryption is called, it's only focused on addition side. Another is on the multiplication side. Like if you can achieve both, it's called the full homomorphic encryption. So because most of a logic gate can be mimicked by both addition and the multiplication. So if you can do both, then every computation can be using the fully encrypted encryption. So idea of homomorphic encryption is I can calculate or operate or do the search on the encrypted data without knowing what the data in it, without decrypted, and as a result I can send you to the owner of the data, who can then use his private key to decrypt it. So that is really a very good idea, because you can actually put the data on the cloud, and the cloud computing provider can do the calculation for you, So it will be a big boost for cloud computing, as well as for the blockchain enterprise as well. So lots of people working on that. There is a person called NUChain. He published a paper about a few years ago, received lots of attention, and he currently working on IBM. There's lots of company working on this area, on the homomorphic encryption. So any breakthrough in terms of speed and in terms of the complexity on this algorithm will be a big boost, both for computing, cloud computing, and also for the blockchain. There's other technologies like coin joining, ring CT, which I talk about the using the ring signature or ring confidential transaction, and also the what is called the BLS, which is basically Stanford Professor Dan Benet and his co-workers working on the signature aggregation. So that has both like compress the signature and also has some privacy benefit or properties. There's another one which is called SCHNOR, SCHNOOR signature. Someone is trying to making Bitcoin SCHNOR signature aware. Basically, you can use SCHNOR signature to sign your transaction. So there's a Bitcoin improvement proposal BIP on this particular subject about a few months ago. So hopefully that will be implemented as well. So SCHNOR signatures kind of is also good in terms of aggregate the signature. So it's both improves your privacy and also increase the storage, not increase, decrease the storage needs. So these are all the technology which will be leveraged by the privacy in blockchain. There's also lots of technologies. One example is Fabric, which is Linux Foundation, right? IBM is really behind it. It's called Hyperledger Fabric. They basically achieve the privacy by using two sorts of different certificates. The membership certificate is used for KYC, AML, right? To really know who you are. But in terms of transaction anonymity, it's using transaction certificate. So each transaction, you have a new certificate, a one-time certificate. It's kind of a one-time password. Each certificate has its own private key, right? So each time the private key is different, that's you achieve the transaction confidentiality. That's what Fabric use. Another way to use it's called the channel. So in Fabric there's different channels, and in the channel you can basically define the privileges for each users. So if you don't have the access right, you have you cannot see any data. So read access or write access, you don't have it. So that also improves the privacy. Similarly, R3 has a Corda. Right? Corda is also kind of consortium chain. It's using the similar channel idea to protect the data using the access control. The Intel has the hardware technology to encrypt the data. So within the SGX, which is called a Secure Guard extension, within the Intel, it has a private key. That private key, no one can really extract it. It's all secure. So everything inside it, no one can. So the only like a privileged process can have access. All other process cannot have direct access to it. They have to go through the manufacturer has to be certified in order to do it. So those are all the privacy technologies. So my thinking is in the future there is a software solution, there's also hardware solution, but the fully anonymous or full privacy, although it's good, but the government may not like it because you have to do know your customer, KYC or an AML, anti-money laundering, and so I see that in order for this really to work in the real world application, you have to have a balance. So that's like what's the best balance? People still working on it, and I think there will be some optimal solution. So basically, you can both protect the privacy of the users and also can achieve AML KYC. So that's the one prediction I have. Another prediction is I think the most of top blockchain project, Bitcoin, Ethereum, Ripple, all those top 10 blockchain projects will introduce privacy features in order for it to have more wide adoption. And I know that most team working on it, especially the Bitcoin community and also Ethereum community. So thank you so much. If you have any comments, please let me know. Thanks.